Okay, everyone, Miss Vogue here yet again, and we are moving on to a packet all about angles. So this is going to be the Pearson angles packet, okay? It will be attached to this video as well, but all we're going to do is learn about angles and apply what you just learned about solving equations to that, okay? So to start off here, we have a skier, and I went ahead and drew this circle around the skis. And remember, anytime you have, I'm saying that these skis are like forming the circle, and anytime you have a line through the center of your circle that touches both sides of the circle, remember, those are called diameters. So these skis here are diameters, and right here where I put this dot, that would be about the center. Okay? So just a little refresher, anytime you have a circle, remember if we were talking about degrees measurements, that's going to be 360 degrees, okay? Now down here in part A, we have list all pairs of angles that share a ray. Now a ray, it forms a straight line. It's basically anytime you have a line that goes on forever in one direction. So like any of these things that I'm drawing here, these are all rays as long as it's only going in one direction. And something special, a line or ray, in terms of degree measurements, that's always 180 degrees, okay? Always, always, always. So for our first question here, we have list all pairs of angles that share a ray. So I'm going to go ahead and look at just this line I have here in red. Now, looking at the left side of my ray that I just drew here, we have angles 1 and 2. So right away, angle 1 and angle 2 are a pair that share a ray. They're sharing that ray on the left side. So similarly, we could say that 3 and 4, since they're on the other side of that ray, are also sharing a ray. So angle 3 and angle 4. So that's all the angles that are sharing that ray. So let's go ahead and look at our other ray here. Draw it in blue this time. So looking below, we have angle 1 and 4. So I'll keep that down here. Angle 1 and angle 4, those are sharing a ray. And then above here, we have, my 2 erased. We have angle 2 and angle 3. So we do have 4 different pairs of angles that share a ray, okay? Now, for part B, it says, suppose the measure of angle 1 increases. What happens to the size of angle 2 and angle 3? So what I'm going to do is just draw a scenario here, okay? So again, here's what our original one looks like, and we want this angle 1 to get a lot bigger. So in order for it to get a lot bigger, we'd have to draw our other ski, we'd have to shift it this way. And now you should be able to see that this angle 1 is way bigger than it was above, okay? So here would be how we'd label our new angles. So let's look above here. I'll go ahead and do this in, we'll do green. So look at my new angle 2. We're trying to see what happened to the size of angle 2. Angle 2, if you look way up here, notice how it got way smaller, okay? And then let's look at angle 3. I'll go ahead and do this in blue. And again, looking right up here, right up there. Angle 3 got a lot bigger. So again, once we made angle 1 bigger, angle 2 got smaller, and angle 3 bigger. So for part C here, how does the sum of the measures of angle 1 and 2 change when one ski moves? Now remember, we'll go ahead and look at this drawing that I just made. When we changed the position of the skis, so here I'll go ahead and do this in, we'll do purple here. When I changed the skis, right here, this is still a straight line, okay? So my angle 1 and my angle 2 are still going to be 180 degrees. Remember how I mentioned that right up here. A line or a ray is always 180 degrees. So we know that the sum is going to equal 180 degrees always. Because no matter what, even if we're making angle 1 way bigger, we're equally making angle 2 way smaller. So it's a constant shift and change, but they're equal on both ends, okay? Hopefully that makes a little sense. a little bit more sense. And then that's also more in detail on your guys' key that I will have posted. Okay. So moving on here, we have a couple of examples that this packet gives you to work or to look through. So I'm going to go ahead and go over some of them with you guys. Okay. So looking down here to the left, this little blue section, okay, we have angles opposite each other are called vertical angles. So I'm going to put that in blue. Vertical angles always have equal measures. So I went ahead and color coded that here, and we have angle ABC and DBE are vertical angles. So whenever you're naming an angle, here we had angle ABC. That's how you would name it, right in order. So here, maybe I'll do some highlighting. A, B, C. Whatever that middle letter is in your angle, that's your point or your vertex on your angle, okay? So we have ABC and then we have DBE. So these two angles are going to be congruent or equal. They're vertical angles, okay? So that's what these little red lines here mean. That just is representing that they're equal, all right? And we also have what are called adjacent angles, okay? And that's non-overlapping angles that share a ray. So looking here, we could say angle EBD and ABE. So here we go, ABE, EBD. And if you notice right here at EB, this ray right here, this is their shared ray. So they are in fact adjacent because one of their sides are both the same. Okay, hopefully we all see that. So looking over here to the right, we actually have an example worked out for us, okay? So we're looking up, way up here at this picture. Now, we were told that angle ABC, okay, I'll write that brightly so we can see, and angle EBD or DBE, you can say it either way, EBD or DBE, as long as that B is in the middle, those are going to be equal. If you can faintly see it, we do have those two little lines indicating that they are in fact equal. So they are vertical angles. So this little M, just like it says, that just means the measure of an angle. So we know that the measure of angle ABC and the measure of angle DBE are equal. So then we just go ahead and replace ABC with this x plus 35 that's up here on the left side of our picture. And we replace our DBE with that 2x minus 10. So now that you have this, you should know exactly what to do next. That's what you did all the last 2 weeks. So all you have to do is solve for your x. We get our constants on one side and we get our variables on the other, and we do get x equal to 45 there at the end. And then if you look up here, we also have find the measure of an angle in the intersection. So all they did was take that x equals 45 and they plugged it in. They replaced it. They substituted it in for the x for one of those angles, and we did get that they were 80. Now it doesn't matter which one we plug this into since they are both equal. Regardless, we should get they are equal to 80 degrees, okay? Which is what that's saying right there. So down here under our try it section, we have angle MNQ and PNR are vertical angles. So again, we can go ahead and draw in those little symbols to show that they are equal. And we want to find the value of x. So first we got our fill in the blanks here. Oop, and I think you do have a fill in the blank right there. We have vertical angles are equal. So the equation would be 3x minus 6 is equal to 114. And that's what we're going to use to find x. So down here, I'm going to go ahead and do that. We have 3x minus 6 is equal to 114. Again, remember drawing your line for your equal sign. We only have one variable term, so we're going to go ahead and get that by itself by adding 6. Remember, we're doing the opposite of subtracting 6 to get it to the other side. And we get 3x is equal to 120. And again, remember, we want to get that x by itself. So how do we undo multiplying it by 3? We divide by 3. And we get x is equal to 120 divided by 3, which is 40. Okay. All right. Last few examples here. So we have ray EG splits right angle DEF into two angles, all right? And we're going to be talking about complementary and supplementary angles. So complementary angles are just any angles that add up to be 90 degrees. And it's always going to be in this L shape. That's what 90 degrees looks like. And this little square right here, that's an indicator that you have 90 degrees. So all they did was they took the two angles that made up this right angle. And again, you could have more than just two. But we had DEG and GEF equal to 90. And then they solved an equation and they should have gotten x is equal to 18. Same idea over here on the right. They just added up the two angles and they set it equal to 180 because supplementary angles have a sum of 180. Okay, so the only difference here between everything else we've been doing is complementary adds up to 90, supplementary adds up to 180. Okay, all right, so looking down here, our final example, we have to find the measure of angle PAR. So we're looking for this right here. They have a little question mark there for us. All right, so we need to find the value of x here first. Okay, anytime you have an x, it's usually pretty safe to assume that you're going to need to solve for it. So we can see that KAR, angle KAR, and angle GAU, or UAG, are congruent or are equal. Again, those are vertical angles, so we do know that those are equal to each other. So that's what they did right here. They did 6x is equal to 2x plus 16. They went ahead and solved for x, and they did get x is equal to 4. Now, if you're looking at this drawing here, I'm going to erase some of my markings, okay? Looking at this drawing, remember I said anytime we have this little square right here, that means we know that this is 90 degrees. So we know that this whole angle here is going to be equal to 90 degrees. So that basically means that this 2x plus 16 plus whatever this angle is right here, our question mark angle, that has to be 90 degrees. So what they're going to do next is right here. They are going to plug in that x to get the measure of this angle right here, this 2x plus 16, measure of angle KAR. And they do get that that is equal to 24. So now all we need to do to find our question mark is set up our equation that we know to be true. So since we know that those are complementary angles, like I was saying, we know that KAR, which we just found is 24, plus the measure of angle PAR is going to equal to 90. So this measure of angle PAR, you can always just think of that as just a variable. So you're just solving for that angle measurement, or again, think of it as a variable. You're just solving for it. So they don't go ahead and show exactly what they did, but remember, we're solving for measure of angle PAR. So how do we undo adding 24 to it? We subtract 24. So all they did was subtract 24 on both sides, and they did get that measure of angle PAR is equal to 66. Okay, so I'm going to go ahead and stop the video here, but the rest of this packet, so numbers 7 through, 17, so you got 10 problems, that's going to be your actual assignment that you're going to upload just like you had for your pink packet and your purple packet. Okay, hopefully I will see you soon.